this. I'm so done with math. You're not even gonna use this in real life.
Silence. You do not know of which you speak. This world around you would be nothing without me.
Who are you?
I am mathematics. Come with me, and I will show you.
No, go away. I don't like math. Go, no.
Oh, hello. You must be Audrey. Come here. I am Jehmianne from the National Statistics Authority of the Philippines. So in my field, we usually use exponential functions to determine the population growth of a location over a period of time. So the formula for population growth is exponential because the population grows faster and faster as the population size gets larger and larger. While the growth rate stays the same regardless of the population size. So over here, we have the formula for population growth. This stands for the final population, while this P naught stands for the initial population, while E is a natural exponential with a value of around 2.72. R is the rate, and T is the time. To find the growth rate, you first need to subtract the number of births by the number of deaths, added to the number of immigrants minus the number of emigrants, all over 100. So here is a sample question. In 1950, the population of Luzon is 100,000 with a growth rate of 1.5%. What was the population in 1955? So what you're finding here is the final population. So that is P. P naught is the initial population, which is 100,000. And then R is the growth rate, which is 1.5%. And then T, the time, is 5 years. Since 1955 minus 1950 is 5 years. So you're going to plug it into the equation. So 100,000, the P naught. And then R, growth rate is 1.5. And then the time is 5 years. So plugging it into the calculator, the answer is going to be like this. So Audrey, the growth rate formula is really important to help us statisticians to foresee the population of a location in the future. It can also help guide the government to take action to avoid overpopulation. So, do you have any questions?
No.
Really? Wait! I'm gonna let you see something over here. Where did she go?
If you look at the sales from the first quarter, we see an obvious increase in the management department, but we have somewhat lacking in the property industry. Oh, you must be Audrey. Oriana, chairwoman of C&R International. This is one of our investors, Sophia. I trust Matt sent them to us.
You know that? Yeah, we were students before too.
But enough of that. We have a meeting after this, so let's see this first. In the business world, we use the quadratic function in order to determine how many products we need to produce in order to generate a profit. First, we have the total revenue. Total revenue is represented by Rx, which stands for the unit price times X. Next, we have the cost function. The cost function is represented by Cx, which is the variable cost times X plus the fixed cost. Lastly is the product function. To get the product function, you need to subtract Rx from Cx in order to get Px, the product function. Today I'm going to be showing you how to break even. The break-even point can be achieved when Rx equals Cx. Now consider these figures. These are some of the sales from our company. If the fixed cost is $90, the variable cost is $500, and the unit price is $150, you will be able to determine the Cx and the Rx. The Cx as 500 plus 90x, and the Rx as 150x minus x squared. Now, we are going to be solving. Now, again, Rx has to equal Cx. From the figures I gave you a while ago, 150x minus x squared is equal to 500 plus 90x. Now, if you manipulate these variables, you will get x squared minus 60x plus 500 equals 0. This is what you will recognize as the quadratic equation. Now, solving this, you will get x minus 50 and x minus 10, which will give us the conclusion that x equals 50 and x equals 10. Now that you have achieved the variables for x, you substitute it into the equation for either Rx or Cx in order to get the values. Now after achieving this, you will get this for your final answer, 50 and 5,000 and 10 and 1,400. And these are the number of products you have to produce in order to break even. Now since this is the break-even point, any amount you make afterwards will already give profit to your company. Now, excuse me, I have to take this. Order for your name, Sophia.
So break-even is not the only function used in economics. So we use the demand function, which is a linear function used by economists to study how sensitive demand is to a change in price. So the demand function is Q of D is equal to A minus BP, where QD is the demand and P is the price. So let me give you an example. D is equal to 12,000 minus 1,500 P. So when P is 1, you substitute 1 for P, which is equal to 10,500. But if P is equal to 3, then you substitute 3 for the P, then it will become 7,500. I've realized the importance of functions in economics. So Oriana will be back in a few minutes or so. Take it. Where's Audrey?
Now, let's go back to the newspaper.
You have one more person to meet.
You got the guts to be 30 minutes late to your first training, young lady. Jump 15 laps around the court and do 10 sets of push-ups afterwards. I'm awfully sorry. I mistook you for the new recruit. I'm Coach Boy of the table tennis team around here. How can I make it up to you? Oh, I know. I'll let you in on a secret of sports psychology while I'm waiting for the new recruit to arrive. Now there's a thing we call the speed accuracy trade-off. I know you probably wouldn't expect math here, but we use a logarithm in order to calculate the task difficulty index. As I was saying earlier, the task difficulty index is a logarithmic function of the distance between the starting point and the target, also known as amplitude represented by A, and the width of the target represented by W. So the formula here is index difficulty equals log 2A over W base 2. How about let's do an experiment right now so I can show you. Come with me. So now that we have our data, we can use the formula to compute for the difficulty of the task. Let's compare the difficulty of the first two. The amplitude here in the first one is 200 centimeters. And the width of the target area is 10 centimeters. Plug in the values and you get log 2 times 200 over 10 base 2, which will give us a value of 5.32. The second task has an amplitude of 200 centimeters and a width of 5 centimeters. So we get log 2 times 200 divided by 5 base 2, which will give us a value of 6.32.
So
we can see that the smaller the width of the target, the higher the difficulty.
Oh, I get it. But when...
You're probably wondering how this is useful. Well, it simply shows us that it's harder to target a small area if you want to be fast. If we relate it to real life, it can just be asking if you want to sacrifice a good performance for speed or vice versa. And we can make the decision based on our calculated task difficulty.
Oh, okay. I get it now. Thank you.
Ah, there's the new recruit. Finally!
It is time to go.
Oh, I'd like you to meet Audrey.
Child, do you see it now? Math is behind the decisions humans make every day.
Oh, I get it now. I can't believe there is math in social sciences. I didn't know that functions could be used in so many different ways. Thank you for showing me all this. Okay, let's get back to this.